Okay, I'm going to try a little bit different of a video here, so bear with me. So this video should be watched after you have completed your 4.1 exploration. Um, and so that was questions 1 through 6 talking about the Pythagorean property. This is just going to help solidify some of those things that you learned in that worksheet. So let's see. Our objective here is to investigate the sum of the squares of the cosine and sine of the same argument. So sum of the squares. What that means is we are going to be squaring our cosine. We're going to be squaring our sine. Now, if you look at these graphs, I don't know what is happening. If you look at these graphs, you will see that all of our cosine values are positive. They're positive because of the squared aspect of it. Um, all of the values that were below the x-axis are now in the same spot but above. So they're equal distance away. They're just all positive. So here's our parent cosine function. So we have 1. I guess they're not all equal distant away. That was not correct. The critical values are. So we have positive 1. The zeros are at the same spot. Where it was negative 1, it's now positive 1. Where it was 0, it's 0. Where it was positive 1, it's still positive 1. Where it was 0, it's 0. And where it was negative 1, it is now positive 1. And the same thing happens with this sine function. And so as you're looking at the sine function where it was 0, well, 0 squared is still 0. 1 squared is still 1. 0 squared is still 0. Negative 1 squared is positive 1. 0 squared is 0. And 1 squared is 1. So we are going to be looking at adding this function to this function. And what happens? So in your problem set, you were asked to plug these into your calculator and see what values you get. So you get cosine squared equals 0.7, or cosine squared of 0.7 and sine squared of 0.7. And you get these two values. And you were asked, add these two numbers together. So when you add these two numbers together, you get, let's see if I can make this work here, you get 1. When you get these together, you add them together, you get 1. We could do this the old-fashioned way. 5 plus 5 is 10. We're going to carry our 1. 8 plus 1 plus 1 is 10. We're going to carry our 1. 7 plus 2 plus 1 is 10. We're going to carry our 1. 6 plus 3 plus 1 is 10, and so forth. We're just going to keep carrying our 1 until we get to the end. And 5 plus 1 plus 4 is 1. So when we add these two things together, we get 1. And so the next question was, what do you notice? Well, we notice when we add them, we get 1. Let's look at that a little deeper. So you're now asked to enter these equations into the graphing calculator. And I'm going to rename y1 to f of x, y2 to g of x, and then y3 to h of x. So let's see what that looks like. So I'm guessing that since you're at home, not everyone has a graphing calculator. And so you're going to be maybe using Desmos, because if you have internet access, you have access to Desmos. So we're going to enter in cosine of x squared. Now, one thing that you'll notice is this copious amount of parentheses. You need to know that if you put the squared inside, it is different. This cosine squared, we want to square the entire function. And we'll talk a little bit more about that in just a minute. And so we've got sine squared in there, and then we're going to add them. And look at this. You notice that everywhere that you add it, the resulting equation is 1. And we can even change this into a table. And we're going to go up by 0.1 radians. So 0.1 is 1, 0.2 is 1, 0.3 is 1, 0.4 is 1, 0.5 is 1, 0.6 is 1, 0.7 is 1, 0.8 is 1. Does not matter what you plug in, you're going to get 1. No matter where you add these two equations together, you're going to get 1. So I want to make a side note just really quick about how you enter this into your graphing calculator. I want you to know that cosine squared of x is not the same thing as cosine x squared. Cosine squared of x means that you are going to take your entire cosine function and square it. This means that you're just going to take x and square it. So these are not the same thing. So mathematicians started writing it like this because there was a lot of confusion when they were writing it like this, of thinking that you just square the x, which that is not the case. So I just wanted to make that clear. Our calculators do not write it like this. Desmos will, so you could plug it into Desmos that way. But the graphing calculators, you have to put parentheses around your argument and then parentheses around the cosine. Okay, so I just wanted to take a moment, talk about that. Can we make a conjecture? Can we make a conjecture? Well, what does that mean? Can we make an educated hypothesis as to what is going to happen every single time we add cosine and sine? Well, we have pretty good evidence right here that every single time we add cosine squared of x to sine squared of x, we're going to get 1. So there's our conjecture. All right, so the Pythagorean identity, it's a big deal. The Pythagorean identity is something that you are going to see for the rest of your pre-calculus and for the rest of calculus. It is a pretty cool identity. And it's just that cosine squared of x plus sine squared of x, no matter what the x value is, you will always, always, always get 1. And knowing this, you can always substitute in a 1. Now, it might be wise to memorize this. And I know because you can't see my face right now, you might want to see it. Memorize? What? Yeah, it might be wise to memorize this. Now, an easy way for me to remember it, for me to memorize it, is that the Pythagorean theorem is a squared plus b squared equals c squared. Well, here's a squared, and 1 squared is 1. So this is a squared. So I remember the Pythagorean identity by thinking about the Pythagorean theorem. So we know that tangent of x is sine of x over cosine of x by the quotient property. I'm going to write that on here just so that we know what it's called. That's the quotient property. And we know that cotangent of x is cosine of x over sine of x. So could we take this one step further and derive more Pythagorean identities? Of course we can. Let's try it. So I'm only going to derive one of them. And then what I would like you guys to do is try to derive the other one. So I'm going to derive this one here by, what should I do? I want a tangent of x. Well, tangent of x is sine over cosine. So this, if it was divided by cosine squared of x, that would turn into a tangent of x. So I'm going to take this entire equation and I'm going to divide it by cosine squared of x. So I've got cosine squared of x plus sine squared of x equals 1. Divide everything by cosine squared of x. I did that because this piece right here is going to be a tangent of some sort. So cosine squared of x divided by cosine squared of x is 1. Sine squared of x divided by cosine squared of x is tangent squared of x. And 1 divided by cosine squared of x, I'll write that here. That's actually a reciprocal identity. 1 divided by cosine is secant. And so 1 divided by cosine squared of x is secant squared of x. And we just derived another Pythagorean identity. You could create a third Pythagorean identity by dividing everything by sine squared of x. Go ahead and try that. Oh, before we talk about our assignment, I guess I don't know how to go back. Don't worry, just bear with me here. Before we talk about our assignment, I would like you guys to know that you can also rearrange this in different forms. So we could rearrange this so that we just have cosine squared of x equals something. Well, if I want cosine squared of x equals something, I would subtract sine of x. So if I want cosine squared of x equals something, I could do 1 minus sine squared of x, just applying algebra. That's another Pythagorean identity. That is another way to substitute something in for either this or for this, because what this means is these are equivalent. We could do that for sine squared of x. So sine squared of x equals 1 minus cosine squared of x. These are equivalent. That's another Pythagorean identity. And you can get all of the Pythagorean identities by just knowing this one. So your assignment today is just a quick review. What is the exact value of cosine of 30 degrees? What's the exact value of sine? What I would like you to do is pause the video here, answer these questions, and when you unpause it, the answers will be on the screen. So here are your answers. Hopefully I didn't make a mistake. I did go through those quickly. Well, thank you for watching. I hope this was helpful.